All right, I want to take a look at the derivative of the sine and the cosine and do it algebraically. There's a couple of things I need to remind you of, or maybe remind you of one and teach you the next. But back at the beginning of the quarter, we looking at limits. This is a limit that we did, might have even been the first example. The limit as x goes to 0 of sine x divided by x. And if you have your calculator in radian mode, which I hope you do because this is a calculus class now, that this limit is equal to 1. Essentially, the sine curve passes through the origin with slope 1, and the line y equals x passes through the origin with slope 1, so that when x is close to 0, it's really hard to tell the difference between the two, that x and sine x are practically the same number. So when you make this fraction, you get an output that's practically 1. So anyway, that was a limit that we had, and I'm going to need this in my calculations. I'm also going to need to know this limit, and I could draw a picture. Actually, we'll do both. When I look at the cosine x minus 1, that's a cosine curve that's been shifted down 1. Cosine curve should start up at 1 and then head downhill. Well, now it's down here. And then the denominator looks like just y equals x. Right? And what I notice is that the numerator comes into the origin. If I zoom in on that, the numerator comes into the origin flat. Right? This is coming in with slope 0. So this gets up to 0 really quickly, where the line kind of takes its time here getting there. So it feels like the numerator of this fraction is really small compared to the denominator, and I'm guessing that this is probably 0. But let's actually do that calculation. And the way I do this is I turn it into this one. So I'm going to multiply by 1 of the form cosine x plus 1 divided by cosine x plus 1. So essentially the conjugate of that. So this is equal to the limit as x goes to 0 of cosine squared x minus 1 over x times cosine x plus 1. The cosine squared x minus 1, actually, I'm used to it this way. 1 minus cosine squared x is the sine squared x. So I have a negative of that. So the numerator is negative sine squared x. So this is the limit as x goes to 0 of negative sine squared x over x times the cosine x plus 1. And then I'm going to split this up like this. This is the limit as x goes to 0 of sine x over x. So take one of those signs with the x, and the limit as x goes to 0 of negative the other sine x over cosine x plus 1. The limit of a product is the product of the limits. So these two things multiplied together are that fraction, and so I can do it this way. What I've done is I've isolated the 0 over 0 problem that I can handle here. This one right here I know is 1, and so then I'm going to say times whatever this turns out to be. Well, this, when x is going to 0, the numerator looks like 0. The denominator, the cosine of 0 is 1, so this looks like 1 plus 1. So this is a 0 divided by 2, which is just 0. And then you multiply by 1 and 0. So this limit here is equal to 0. Okay. Now, let's use that to find the derivative of the sine. So I've got f of x equals sine x. And what I want to do is I want to look at f prime of x. I want to take the derivative. I'll use the definition because I don't have a shortcut rule yet. I'm going to create one right now. So I'm going to look at the limit as h goes to 0 of the sine of x plus h minus the sine of x all over h. Right? That's the definition with the sine plugged in here. How's your trig? I want to use an identity here. Sine of a plus b, sine of the sum of two things here. This is the limit as h goes to 0. This is the sine of x times the cosine of h minus the cosine of x, not minus, plus the cosine of x times the sine of h. Right? Remember that identity is sine of a sum. Anyway, and then I still have the minus sine x all over h. Okay. Now I notice that the first thing in the numerator and the last have a sine x in it. I'm going to factor that out. So I've got the limit as h goes to 0. I've got a sine x times just the first one and the last one. There's a cosine h here, and there's, well, the sine x can't factors out, so there's just a 1 left. And then I've got the cosine x sine h. And I'm dividing by h. What I'm going to do is I'm going to divide this by h, and I'm going to divide that by h. Essentially, if you're adding fractions, you get a common denominator, so that's what I have. And then I can break this into this limit into the sum of two limits. So this is now the limit as h goes to 0 of sine x cos h minus 1 over h. I'm going to write it this way. I mean, it's just multiplying by sine. And then I'm going to add that here, the limit as h goes to 0 of the cosine x times sine h over 1. Now, I'm looking at those two limits that I just talked about up above. As h goes to 0, this thing right here goes to 0, and this thing right here goes to 1. So what I'm looking at is the sine of x times 0 plus the cosine of x times 1, which leaves me just with the cosine of x. So where did I start? I just started with that the function was sine of x, and the derivative is cosine of x. So sure enough, the derivative of sine x is cos x. And we are going to do the derivative of cosine x while we're here as well. Okay, so here we go. F of x equals cosine x. What's f prime of x? Well, by definition, it's the limit as h goes to 0 of f of x plus h, so cosine of x plus h minus f of x, which is just cosine of x, all over h. And I'm going to do the same thing as last time. Well, similar thing. I've got cosine of a sum, so I'll use the cosine identity, cosine of a sum identity, which is the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. Right? And then I've got a minus cosine x all over h. And I notice that I got a cosine x I can cancel, not cancel out, but factor out. The limit as h goes to 0. Cosine x, I'm factoring out just from the first one and the last one there. So I've got a cosine h minus 1, cosine h, and then a minus 1 from there. And then I've got a minus sine x times sine h. And the whole thing is divided by h, so I'm going to divide each piece by h. Okay. And again, breaking it up into two limits now. The limit as h goes to 0 of the cosine x times cos h minus 1 over h minus the limit as h goes to 0 of sine x sine h over h. And again, this one right here I know goes to 0. This one right here I know goes to 1. So what am I left with? The cosine times 0 and negative the sine of x times 1. So this is negative sine x. There you go, the derivative of the sine and the derivative of the cosine.